Hello everyone, I am back. Sorry I've been gone a while, but I have been doing digital work. I have been taking my 3D models and converting them into a format that I can use, and then slicing them with a slicer so that I can 3D print the models. I've been playing around with different dimensions and stuff, trying to optimize this as best as I can. My goal is to print out my models. I have a chassis model of a C8 Corvette with the body taken off, most of the body taken off. And then I plan on printing out the new body styles that I have designed and trying to fit them on the C8 and seeing what works and what doesn't. I do know that the designs I currently have will not fit. I checked it out on the computer digitally with the 3D models. So what I'm planning on doing is printing multiples of those bodies, slicing them, getting them to fit onto the C8 chassis, and then I will fill in the blanks afterwards. Then I will scan that and use that as a model going forward. But before I do that, I need to print them. I've been working with a Modix printer. It is a Modix 120X. It does, 600 millimeters in depth, 1200 millimeters in width, and then another 600 millimeters in the Z, up and down. That translates to 2 feet by 4 feet by 2 feet in depth, or in the Z direction. The problem is, I've been working with it for over a month and I have not been able to consistently get it to make a good print. So, I had parts ordered. I've been waiting over a month for the parts to come in. In the meantime, I saw a coupon for Micro Center, and they have a $100 off of a specific printer. That specific printer is this one. It is an Ender 3 Pro by Creality. If you look, Creality makes a lot of printers. A lot of them are called their Enders and Ender 3, and some of them are Pro, some of them are 1s. So you have to really look. This is, I think, their least expensive printer. I'm not positive on that, but it's listed for $200 at Micro Center. With the $100 off coupon, it came down to $99. I looked at their other printers. Those of you that are familiar with printers, there are a lot of upgrades you can make. The one I wanted, the best one they had there that I wanted, was almost $500. But even it won't do much better. It's like a couple of inches bigger in each direction. Still not big enough because I need to print a large scale. Let me go get that. I need to print something at least this big, and none of those printers would do it. So there's no point in paying $500 for something that still won't do what I need it to do. The large printer, of course, the large format one will easily print this. In fact, it'll print one 2-3 times this big. But I haven't gotten it to work yet. So, what I found is all printing is a learning experiment. So rather than, and the printer is an hour away from here. So every time I would go to work with it, I'd have to drive an hour, work on it. Most of these prints take several hours to several days to print. So I would drive out there, get it working, start a print. I'd have to babysit it for a while because it would typically print for about 2 hours, and then the extruder would stop extruding. I'd have to manually play with it. Sometimes I could get it going again. Other times I couldn't. And of course I didn't want to just stay there and babysit it the entire time. So then I would drive back. So basically I could get one print done in a day if I'm lucky. If anything goes wrong, that whole day is wasted other than finding out what didn't work. By buying this, I can play around with all the different parameters and figure out what works, what doesn't work, and possibly get some help on how to get everything to work. The other advantage to this is there is a huge user base. So when you have problems, you can ask and somebody will answer. The problem with the Modix is it is not a mainline printer. There is not a slicer directly made for it. And getting help on it has been hit or miss, mostly miss. People seem to guess at what's wrong, and it's typically things I've already tried. They get frustrated because they think I'm ignoring them. I'm not ignoring them. I've already tried those things. I'm an engineer. I do things systematically, so I've already tried all the simple things that they suggest. So they get upset and stop helping me. So I'm going to go ahead and try on this one and see what happens. So what this is an unboxing video where I am going to unbox this and show you what's in the box. And then once I do that, I will do a assembly. That's the other thing with this, you have to assemble it. I've heard estimates anywhere from 20 minutes to a couple of hours to assemble it. I'm going to find out myself how long it does take. I'm hoping it doesn't take a couple hours. I'd be shocked if I could do it all in 20 minutes. So somewhere in between there. The other thing is, this is an unboxing video, but you can see it's already open. The reason why is when you buy it, inside this box is a $10 off a spool of filament. This is PLA filament. It is retail for $18.99. By using the $10 coupon on it, it knocked it down to $8.99 or $9. Very nice. The woman that was checking us out, she had just bought one 3 months ago, and obviously didn't find the coupon until she opened up the box and found out, wow, if I'd known this, I could have used it. So she opened it for us and got the coupon out, and I got the filament for $10 off. All right, let's get to it. So we all go ahead and open up the box, and we can see that there is a documentation. Let me go ahead and pull this out. See what we've got. All right, so there's a sticker, reality sticker. Instructions for assembly. Now, I've watched several online videos, and they've recommended going and getting the latest and greatest documentation because there might be some upgrades or changes. But also, when you think about it, the instructions that came with this printer probably are up to date with this printer. So maybe the newer instructions have the changes for a newer, maybe some changes or enhancements have been made, I don't know. I'm going to try to follow this by the letter, and we'll find out what does and doesn't work on it. Then there is a warranty card, and it says nothing significant, but does have a code there to use. And then of course a warranty card. All right, pull out the phone here. Let's see what we've got. All right. And obviously some assembly is required. Let's pull these out and see what we've got. This is the display panel. Look at the videos. This is a pretty nice display panel here. So that goes off on the side. Let's see what else we have here. Everything here wants to come out at once. Go ahead and do that. This is the actual table. Not sure how this comes out. We turn it up on the end. And of course it is solid on the bottom. All right, so this looks like it is the main power supply. And what's this? These are the rails. I assume these are for the Z direction, the up and down. And then the entire base is right here. This is the extruder. So here's the linear base and the extruder. 2 motors. And this is where the filament will come through. This does the tension, filament comes through here. This is the tension on the filament. Motors turn and advance the filament through here. And that's all that's in this. Then we go down to the next layer of the box, like so. Here is the power cable. Comes with a spatula. You need this to remove the part from the filament, or from the table when it's done. Here is the spool holder. Here is what I'm guessing is the Z-axis motor. Some more slides, longer than these. And a bag of wrench, a screwdriver, some Allen wrenches, tie wraps, belts, some screws, hardener fasteners. Here is a slide. It has 3 plastic wheels that guide it on the rail. And the last one is, oh, they give you a little bit of filament. That wouldn't do a whole lot. A couple of micro switches, some fittings, adapters. There's a nozzle right there. It comes with a 0.4 millimeter nozzle. Small for what I'm doing when I do my big parts, but as an experiment, I'm going to just do this exactly out of the box with absolutely no changes and see how it works. Okay, pull this out just to make sure there's nothing else in the box. All right, that's it for the unboxing. So I'm going to go ahead and end this, and the next video that I do will be assembling this thing. So we'll see how difficult it is to assemble, what kind of work it takes, and I'll go through step by step, hopefully find anything that's hidden or that you need to know in the process. And we'll assemble it. Once I've assembled it, I already have the parts in the computer. I have them sliced using Creality Slicer. One of the advantages of this printer is not only is it popular, but they have their own slicer. The slicer is kind of like the magic to make all of this work. It tells the printer exactly what to do. And the advantage of this printer is the manufacturer of the printer also makes the slicer software. So you know it's going to be, or you're relatively confident, it's going to be the best slicer that you can use with this printer. There are other slicers available. I may try that. When you get into the slicers, there's probably 100 different settings that you can change. The problem with the generic slicer is it's not made for your specific printer. It's made for a lot of different printers. And so I think a big problem with the Modix is that the slicer is not exactly for it. And so I'm playing around with kind of guessing at making changes. People are helping me to guess with making changes, but I just haven't had any luck. I am waiting on the parts for the Modix. When they come in, I will switch to using it. In the meantime, I'm hoping to get a couple of parts printed with this. The fastest print I have is down to 1 day. What I did was, I initially thought I wanted to maximize the size of the parts that I did. So I put them at an angle like this, since the longest dimension is up and down, and it's 250 millimeters. When I scaled the part to common sizes based on models of cars, it came out to just barely over 250 millimeters, but it would not print it or slice it because it was over 250. So then I had to put it up on end and slant it. And when I did, it came out to take over 2 days to print. Then I decided, wait, what if I don't try to get it as big as possible? I set it flat on the table there, which is only 200 by 200, and then pick the biggest size that would fit on that. I did that, and it cut the time down in half, cut it down to a little over a day. The first one was 60 hours. When I put it down on flat, it was a little under 30 hours. And so I literally used half as much material, and it will print it twice as fast. So because I am printing all the parts that I need, I don't have to stick with any of the common sizes. Those would be like 1:18 to 1 or 24 to 1 for the models that you buy. But since I'm doing everything on my own, I can print everything to the same scale. And I will probably end up printing it 20 to 1 because that's going to make it easy to take those numbers, measure them, and then multiply them by 20. And that'll be how big the real size part R is. So my whole goal is to actually make a full-size car out of this. So in order to do that, I need the real dimensions. So I'm going to go ahead and head off in that direction. I also have a car that I'm building from scratch, frame and everything. And for that one, I need to model the frame, print out everything, and make sure it's going to fit before we go and have the metal. The chassis is going to be all aluminum, custom cut and made, designed. And it's going to use a C5 Corvette suspension, which I also have models for that. So I am going to build everything on the computer, slice it, 3D print it, assemble it on the table. It should be, about so big. Again, less than 8 inches. The 200 millimeters is 7 3/4. The 250 millimeters is 8 3/4 inches. So obviously the longest dimension will be 8 3/4 inches. Unless I wanted to print it in pieces. Of course, I could print it in half and make it twice as big. I don't know that there's anything to be gained by that, so I'll probably just print everything 20 to 1. I think will fit on that size. The other thing I forgot to mention, it has a magnetic plate here. So the advantage of that, some of them have glass, some of them have metal, and then this one has metal with a magnetic plate on top of it. The advantage is sometimes it's hard to get the parts off of. It's a game between getting the parts to stick to this and also being able to get them off afterwards. Ideally, you're not supposed to touch this because the oil in your fingers will get on there and could make getting the parts to stick difficult. You can wipe it down with IPA, isopropyl alcohol. They say to use the 99% because the percentage that's not 99% is water. So anyway, this just goes right on top of here. It does stick very well, so you want to try to line it up as best as you can, and then let it snap down because it does not want to slide to adjust after you put it in. All right, that's all I've got. Like, subscribe, hit the alert. If you want to donate, hit the thanks. And if you don't know what I'm doing, you don't know Jack. Bye.